Consider the graph of the function f of x equals 10 minus x squared on the interval from 0 to 3. We're going to find the area using 3 left and then 3 right. Okay. If you recall from chapter 10, 10 minus x squared would take your standard U-shaped parabola, reflect it over the x-axis, and then move it up 10 units. So approximately, because we only care about from 0 to 3. I mean, the graph does go this way as well, but it's a parabola that opens down. So if you 0 into the function, what do you get for f of 0? 10. So that means this height is 10. You put 3 into the function, 1. So my drawing's not exactly the scale. So we're going to find 3 left rectangles for this picture. So let's actually draw this in. So starting at 0, I had to go up to, move over the width, and then come on down. Starting at 1, go up to the function, over the width, and then come on down. And then 2 is the last left side. Totally misjudged that, that's okay. This is an art class. Well, the area of a rectangle is length times width. What's the width of all these rectangles? 1. Is that okay? So that part's easy. The length happens to be how far up it went. So notice since this was a left-hand rectangle, we actually went up to where the graph touches at x equals 0. So in other words, this is really f of 0, that's the length, times the width is 1, the width. So that's the first rectangle, plus, how far up did we go for the second rectangle? How did you get 9? Yeah, so we did the left-hand side, f of 1, times the width, 1. So that's the second rectangle, plus, how'd you get 6? Put in 2 in for x, times the width. So as I was saying earlier, we don't need the picture, because if you know what your intervals are, notice they are 0 to 1, 1 to 2, 2 to 3, and you're doing left hands, then you only use the left-hand side of those intervals, 0, 1, 2. So f of 0 we found to be 10. F of 1, you would get 9. And f of 2, you would get 6, was it? So what is 10 times 1 plus 9 times 1 plus 6 times 1? By looking at our picture, is this an over or under approximation? Over, because notice most of our rectangle, not most, but some of our rectangles on the outside there, we only care about from 0 to 3. Oh. We don't care about anything else.
Not the whole thing.
Not the whole thing, correct. So this would be an over approximation. I do not want you to assume that every time that it's a right or a left-hand rectangle that it's an over. It depends on the function. So how about the other side, the right-hand side? I'm going to get rid of this stuff. This was not proper planning. Oh, I'm just going to have to redraw the whole thing, aren't I? It's okay to say yes. Yeah. Am I going to make it? Oh, so close. That's all right. So what numbers are we going to use for the right-hand rectangles? 1, 2, 3, because those are the right-hand sides of the subintervals. So 0 to 1 is the first subinterval, 1's on the right. 2's on the right, 3's on the right. So you would start at 1, go up to the function, but this time you would move left. Start at 2, go up to the function. Start at 3, go up to the function. So by looking at the picture, is this going to be an over or an under approximation? Under, because we're missing these parts. So what's the setup in terms of function notation like we have in the first line there? What's the first height of the rectangle? Half of 1, and the 1, plus, what's the next one? Half of 2, and the width is 1. And the last one? And the width is also 1. So half of 1 we previously found to be 9. Half of 2 we previously found to be 6. And half of 3 we had said before was 1. So what is 9 times 1 plus 6 times 1 plus 1 times 1? And as we said, that's an under approximation. So if 16 is an under approximation and 25 is the over approximation, then we can say that our actual area is in between 16 and 25. Very good.